Hey, welcome back, guys. Section 2 of Chapter 7, the ambiguous case of the law of sines. It's going to be a lot of fun. First of all, in the previous section, 7.1, I want to draw your attention to something that we were doing. We were solving oblique triangles, right? All of the oblique triangles that you and I looked at in 7.1 were either SAA or ASA. What that means is all of the triangles that we looked at in the previous section, and for both cases, two angles were given, right? Two angles, right? One of the cases, the two angles were given and the side included within the two angles was given. This case is two angles are given and the side that's not included within the two angles is also given, right? So notice for both of these cases, you have two angles and one side, a pair of angles and one side. Sometimes that side was included within the two angles, other times that side was not included. For every single case, however, in the previous section, you and I were able to solve for one unique oblique triangle, one unique solution, one unique triangle every single time. Here in 7.2, the reason why it's called the ambiguous case is because all of our triangles, all of the information they give us is going to be of the form SSA, two sides and one angle. Two sides and one angle. And what's very important is that the angle that they're giving you is not included within the two sides. So what this means is, for each of these problems, you're either going to have one triangle exists for the given information, two triangles exist with the given information, or no such triangles exist for the given information. Now we're going to be using the law of sines, but I want you to keep some things in mind when you're actually using the law of sines. First of all, if you find that sine of an angle, theta, let's say, is equal to 1, well, that just means the angle is 90 degrees and the triangle is a right triangle. If you find sine of an angle, keep in mind that supplementary angles have the same sine value. So sine of theta is equal to sine of 180 degrees minus theta. Sine of theta is equal to sine of the complement of theta. The supplement of theta. Sine of theta is equal to sine of the supplement of theta. Like, for example, sine of 30 degrees is equivalent to sine of 150 degrees because 30 and 150 are supplements. Sine of, 45 degrees is equal to or equivalent to sine of 135 degrees, and so forth. Supplementary angles have the same sine value. Last but not least, something that we talked about in the previous lesson, the smallest angle is opposite the shortest side, the largest angle is opposite the longest side, and the middle valued angle is opposite the intermediate side. So let's keep this information in mind as we tackle our first example. I'm excited. Here we go. Solve triangle ABC if side A is 17.9 centimeters, side C is 13.2 centimeters, and angle C is 75 degrees and 30 minutes, which is the same thing as saying 75.5 degrees. Now, I want you to keep in mind on how this is the SSA case. Two sides are given, and angle C is not within the two sides, is not included within the two sides. After all, the angle that's included within these two sides is angle B, and that's not given. It's angle C that's given. So this is definitely the SSA case. All right, so let's do it. Let's set up the law of sines. I set up my law of sines like this because A is given, C is given, angle C is given, angle A is not given, okay? Whatever I'm finding, whatever is unknown, whatever is the variable, I try to write it on top, right? So what I will find is that sine of angle A, is equal to side A times sine of angle C divided by side C. So sine of angle A is equal to 17.9 centimeters times sine of angle C, which is 75, degrees and 30 minutes, or 75.5 degrees, and then all of that divided by 13.2 centimeters. Let me move this down a bit. And when you punch this into the calculator, you'll find that sine of A is equal to, okay, you guys, I'm getting 1.312866876. This digit right here is an 8. So this is not good, because you and I know that no matter what A is, whatever angle that is, the range for sine says that you have to be between -1 and +1. Remember that? So no matter what A is, no matter what that angle is, sine of that angle is not allowed to be greater than 1. So that means there's no solution. No such triangle exists. Okay? You can't form a triangle with the given information. It's kind of like saying no solution. So always look out for this, guys, when you're doing your work. If ever you're getting a function value for sine that is greater than 1, stop right there and say, nope, no solution, or say no such triangle exists. Cool, let's go to the next example. Okay, everybody, example 2. Solve the triangle ABC if angle A is 61.4 degrees, side A is equal to 35.5 centimeters, and B is equal to 39.2 centimeters. Okay, cool. Let's set up the law of sines. I noticed that they give me angle A and side A. They give me side B, but they did not give me angle B. So I'm going to write the law of sines with angle B in the numerator. All right, so here's my law of sines, which leads me to the statement that sine of angle B is equal to B times sine of angle A, all of that divided by side A, which means sine of angle B is equal to 39.2 centimeters times sine of angle A, which is 61.4 degrees, and then all of that divided by side A, which is 35.5 centimeters. Okay? Now I'm going to punch this into my calculator, guys, all of this. Now watch this. If all of this turns out to be more than 1, I'm done, and I say no such triangle exists. All right? Okay, I got sine of angle B, is equal to 0.9694910. So this value is less than 1, so we are good. Let's continue working. So this means B will be exactly equal to inverse sine of this number. Okay, let me figure out what that is. Okay, B is about 75.8 degrees. Okay, guys, now, do you remember that we had said earlier that supplementary angles have the same sine value? So what we need to do right here is find the supplement of angle B. So the supplement of angle B is going to be 180 degrees minus 75.8 degrees, which is 104.3 degrees. So what's really important for you to understand is that sine of this angle will be 0.9694910, and sine of this angle will also be 0.9694910. So what I'm trying to show you is you have two options for B. Either B could be 75.8 or 104.3. Now, this second option for B is only valid if this angle plus the other given one is less than 180. So this is what we have to check, everybody. We have to check that this second option for angle B plus the given angle A is less than 180 degrees. That is to say, 104.3 degrees plus 61.4 degrees must be less than 180. And it is, because it's equal to 165.7 degrees, which is indeed less than 180 degrees. So then this option is good. Now, if this second option plus angle A were more than 180, that would leave me with no room for angle C. the other unknown angle. So then I would take this second option for angle B and toss it in the trash, and there would only be one option for angle B. Okay? But for this example, I'm noticing that I have two options for angle B. Either it's 75.8 degrees or 104.3 degrees. So I have two such triangles in this example. To help me differentiate between my triangles, and I don't want to be confused, I'm going to call B sub 1. I'm going to use some subscripts. B sub 1 is 75.8 degrees. And then I'm going to say B sub 2 is 104.3 degrees. So I have two different options for angle B. B sub 1 and B sub 2. Okay, guys, this is how I'm going to organize my information. Two triangles exist for this problem. Triangle number 1 will be A. Remember, angle A was given. B sub 1 and C sub 1. C sub 1 will be angle C that corresponds with B sub 1, right? And then triangle number 2 will be angle A, the same angle A that was given, B sub 2 and C sub 2, all right? So let's finish off triangle number 1. Okay, if we finish triangle 1 first, notice that we have angle A that was given. We found B sub 1, and we're missing C sub 1. So let's go ahead and find that third angle, okay? Now, angle C sub 1 will be 180 degrees minus angle A minus B sub 1, all right? Because the sum of the three angles within any triangle has to be 180 degrees. So then we're finding that C sub 1 is going to have to be 42.8 degrees. Okay, so there's an answer for us right there. Okay, so we have all three angle measures. Now, side A was given, side B was given. The only side that's missing now is side C, and we can use the law of sines to find it. So C over sine of angle C sub 1, I guess we should call the C sub 1 as well, like that, will be equal to, now let's use given information. So it'll be side A over sine of angle A, like that. So side C sub 1 will be equal to A, which is 35.5 centimeters, times sine of angle C sub 1, which is 42.8 degrees, all over sine of angle A, which is 61.4 degrees. Like that. Okay, so C sub 1, side C sub 1, move that up just a little bit. Side C sub 1 is about equal to 27.5 centimeters is what I'm getting. Okay, all right, triangle number 1 is done, folks. We found the third angle here and the missing side length here. Okay, we have everything we need. Now it's time to move to triangle number 2. Now, let's keep track of what we have. We have A, that was given from the very beginning. We found B sub 2, that was 104.3 degrees. We need angle C sub 2. So let's find that now. Okay, angle C sub 2 will be 180 degrees minus angle A minus B sub 2. So then C sub 2 will be equal to 14.4 degrees, like that. All right, cool. Now we have all three angles within the second triangle. We know side A because that was given. We know side B because that was given. It's just side C sub 2 that is missing. So, law of sines. C sub 2 over sine of angle C sub 2 must be equal to, right? Let's use the given information. 35.5, which is angle side A, over sine of angle A. All right? So then C sub 2 will be equal to, A is 35.5, sine of C sub 2, which is 14.4 degrees, right? And then all of that over sine of angle A. and angle A, sine of angle A is 61.4 degrees, like that. So I'm finding that C sub 2 is approximately equal to 10.1 centimeters. All right, you guys, we're done with the problem, but I just want to kind of summarize everything we found on the next screen. All right, everybody, here's everything that we have. Our two triangles. Now, some of this information was already given, right? Angle A was given, sides A and side B were given. So we found angle B sub 1, C sub 1, side C sub 1, and also for the second triangle as well. So this was a good example, I think, for when you have two such triangles that exist. So you have to be careful about supplementary angles having the same sine value. All right, let's look at the next example. But before we do, I actually have some information for you that I think would help you before we go to the next example. So this is great information for you, not only to read and read through with me right now, but it's great information for you to have in your notes. Let's walk through it. How do you determine the number of triangles that you're going to have, either 0, 1, or 2? All right, so we already saw this case. If sine of an angle, like B, is greater than 1, stop right there. That's 1 is outside, greater than 1 is outside the range for sine, so no such triangle exists. If sine of an angle is equal to 1, well, then only one triangle satisfies that information, and that is a 90-degree angle. Sine of 90 degrees is 1. Okay, so this third one here is what we just finished witnessing. So if sine of an angle is between 0 and 1, that is valid, right? Less than 1, but positive, right? Then either one or two triangles exists. Now, if sine of an angle is equal to a value k, some positive value k, then angle B is exactly equal to inverse sine of k. And you're going to use that angle B as B sub 1 in your first triangle. For your second triangle, B sub 2 is going to be the supplement of B sub 1. So 180 degrees minus B sub 1. Now, this second option for angle B is only valid if the given angle A, the given angle in the problem, plus B sub 2 is less than 180 degrees. And if that's true, then a second triangle does exist. If this is not true, if A plus B sub 2 is greater than 180, then there's only one triangle that exists. So if it is less than 180, then two triangles exist. You're going to use B sub 2 for B in the second triangle. All right, we saw all of this happen in the previous example. Now let's go to the next example and see what happens there. Okay, guys, solve triangle ABC given angle B is 68.7 degrees, side B is 25.4 inches, and side A is 19.6 inches. Okay, let's start with the law of sines. I see side B and angle B are given, side A is given, but angle A is missing, so I'll start with angle A. All right, so law of sines says that sine of angle A over side A must be the same as sine of angle B over side B. That will imply that sine of angle A is exactly equal to A times sine of angle B all over side B. That means that sine of angle A is equal to 19.6 inches times sine of 68.7 degrees, all divided by 25.4 inches. All right. Now let's be clear about something. I'm going to punch this into my calculator, and if I get all of this to be something that's greater than 1, sine of A, angle A, is greater than 1, then no such triangle exists. If sine of A turns out to be a value that is less than 1, but positive, then I will check for two triangles. Okay, guys, this is what I got. That sine of A is equal to 0.7189 and so forth. So what I'm going to do now is take the inverse sine of what we just got. So A is equal to, inverse sine of 0.71894287. Let's move this up a little bit. And then here we go. We are getting that A is about, 40. So we have three significant digits here. So I get 45.967. But if I'm going to round to three significant digits, that's going to give me A is 46.0 degrees. Okay? Now, what I'm going to do, because supplementary angles have the same sine value, I'm going to check for a second triangle right now by finding the supplement of angle A. Okay, guys, we found the supplement of angle A, 180 degrees minus 46 degrees is 134 degrees. Now, this is a second option for angle A. So I'm about to call this A sub 1 and then call this A sub 2. But before I do, I have to check to make sure that the given angle in the problem plus 134 degrees is less than 180. Can we check that real quick? Okay, you guys, this is what I get when I check. I have to make sure that 134 degrees plus my given angle, the given angle is angle B, I got to make sure it's less than 180. So here I go. 68.7 degrees is my given angle B plus 134 degrees is equal to 202.7 degrees, which is more than 180 degrees. So this second option for 134, the second option for angle A is not valid. I do not have two triangles here. I would only have two triangles if I added these two angles and I got something that is less than 180, which I did not. So there's only one triangle. All right, so what have we found? We have found angle A. Angle B was given, so what's missing now is angle C. Let's go find it. All right. So angle C is what's next to be found. It will be equal to 180 degrees minus the given angle B minus what we just found for A. So then angle C is going to be 65.3 degrees. Cool. Now in the problem, sides A and B were given, side C was not given. So let's go find side C. I'll use the law of sines and set it up like this. Side C over sine of angle C must be equal to, let's see if we can use as much given information as possible. Let's see. We have, angle B was given. So why don't we do angle, yes. So we can do side B over sine of angle B because both side B and angle B were given. All right, cool. So then we know that side C will be equal to side B times sine of angle C divided by sine of angle B. All right, which will be equal to, B is 25.4, right? That was given. Times sine of 65.3 degrees is angle C that you and I just derived, over sine of angle B, which is given as 68.7 degrees. Okay? All right, guys. Let's see what this gives us. C is equal to, if you punch all that into your calculator, 24.8 inches. Cool? So here's the final information here. We found angle A, we found angle C, and then we just found side C. Cool deal, everybody. Let's do one more problem before we wrap this up. Okay, you guys, last problem for the section. Solve triangle ABC given that angle B is 93 degrees and side B is 42 centimeters, side C is 48 centimeters. Okay, I want you to think about something in this problem before we go much further. What's going to be the largest angle? A, B, or C? Well, because B is obtuse, we know it has to be the largest angle. Because the sum of the three angles within any triangle must be 180 degrees. That forces angles A and C to be acute. So we have B is obtuse, which means it's the largest angle. That forces angles A and C to be acute. If B is the largest angle, that must mean the side opposite angle B, which we call side B, must be the largest side. All right, so I'm making sure you have all of this in your notes. So we got B being the largest angle, side opposite it must be the longest side, but that's not what's given. Look at C. C is the longest side. So there's a contradiction here. So before doing any work, we can conclude that no such triangle exists with this given information. All right, you guys, if you are doing a problem and you just kind of like jump in it and set up the law of sines, and you forget this logic right here, then you're just going to find the same conclusion after doing a little bit of work. That is to say, the law of sines will lead you to a contradiction. Okay, the law of sines will lead you to a contradiction. Something like sine of an angle turns out to be more than one. And then you're going to conclude that no such triangle exists. All right, you guys. I hope you had as much fun as I did, maybe even more. This is the end of 7.2, the ambiguous case of the law of sines, and the next section will be 7.3, the law of cosines. I'll catch you later.